Um, Next, I'd like to introduce our next speaker, Jean Latiere. Um, we thought the topic of sustainability has been especially top of mind, and there's a lot of things that we do as a technology that complement sustainability efforts that organizations may have. So with that, I'd like to turn it over to Jean to talk about the next section here.
Hi. Yeah, thanks, Jane. And well, thanks a lot for the invitation to speak. You can see me well, hear me well. I hope so.
Yep, I can hear you just fine.
Okay, perfect. So yeah, a couple of words to introduce myself. So yes, I'm cloud advisor. Starting a company a few months ago about cloud optimization. It's about FinOps, the financial optimization of your cloud workloads. It's about cloud automation. It's also about GreenOps. GreenOps, it's how you measure and how you optimize the carbon footprint of the workloads that run in the cloud, and that's really interesting topic. But yeah, first I'd like to start with a bit of knowing from you, from the audience who is there, the attendees, like if we can maybe launch a quick poll, like are you aware of the environmental impact of running your bioinformatics workloads in the cloud? So yeah, single choice, like I'm not aware. Um, Yeah, it has some impact, but I'm not very sure, probably quite limited. Or yes, I'm quite aware of the impact it has. It's quite interesting. I'm quite curious to know the extent to which you're acquainted with this topic, because cloud is often thought as something quite ephemeral, like you have computers in the clouds, so supposed to be clean, so we assume it's all good for the environment. Maybe we can check the results and move to the next question, or move to the next question. Like, do you know how you can reduce?
So it
So
looks like
yes,
we've
you're
got
aware.
general
Good job,
awareness.
guys.
Yeah, it looks
Good
like
job,
we've got
guys.
general awareness, John. But many people still have somewhat limited or no awareness.
Okay, interesting. So yeah, second question then, if you're aware, do you know how you can reduce that environmental impact? Do you know of ways? Uh, so is it like, so we need to launch the question probably. Is it like not really? Or is it that I have some ideas, but I've not tried yet, and I'm already doing it. When I run my bioinformatics pipeline, I have this in mind. So yeah, quite interested to know here how mature you are on this topic. So let's give a few seconds more, and yeah, let's go. Let's check the answers. Yeah, not really. Yeah, because it's kind of tricky. Yeah, let's admit that it's kind of tricky. It's tricky to measure. It's tricky to you can have some ideas and you're not really sure how to try. But then, yeah, some of you probably like they have some ideas and they have tried. You need to measure, you need to see the results. So first, let's talk about the environmental impact of the cloud and what it is really. So here I'm sharing a bit of data on now how cloud is more important than on-premise data centers for the energy that it's consuming. Now it's considered that more than 50% of the IT is running on public and private cloud. Estimated today, so the graph here on the left is a bit old, but it's between 30 and 40% that is on public cloud. It's been growing at compounded rate of 25% over the past 12 years. But the energy itself, it's been growing like the energy consumption 6%. And they are really energy guzzlers. You need like um, oh, yeah. Yeah, a very large data center requires more than 100 megawatts of power capacity, and 100 megawatts, you can power 80,000 American households. So a data center is like a small town, small American town of 80,000 American households. And like the energy consumption can be attributed to various components. So you see the servers, storage drives, the network drive devices, but most important, the cooling systems as well. So as I was saying, the cloud computing energy itself, it's been growing 6% per year over the past 12 years. It's because when we look on the left, we see that there have been some gains in efficiency, and notably the one that you will see, the PUE that we use to measure the efficiency of data centers, the power usage effectiveness. It has really improved, but still, like those efficiency gains, they don't offset the growth and the demand for power. It's not only the power for the operations of the data centers, it's the power needed to manufacture the components, to build the data center, then the end of life, the disposal of all those elements, all those materials. And all this is what makes what is called the carbon footprint. That's how you calculate the carbon footprint, basically, of the cloud. And it's also, you need to account also the metals and the minerals for the servers, the facilities, like all the new chip cards that come every quarter, the new GPUs, and the water for cooling. And what we see now is that the impact is huge. So maybe now, Jane, you can start clicking. We see some news, for example, an outage of an Azure data center in Southeast Asia earlier this year, and due to the heat wave, also this new wave of generative AI use cases, there's a huge demand on the cloud, and also mostly GPUs, and it measures like it's really, you need like a lot of water for this kind of workloads. And Google has made some study and has been quite transparent on this, sharing some numbers, and you can see the order of magnitude there, that we are talking of billions of liters of water necessary to operate data centers. And that also impact like where those data centers are located, because you will have to make some trade-offs with agriculture, for example, and you can have social unrest like you had in Netherlands a bit earlier this year, because of some data centers that were taking water from that was previously for agriculture. So next, how can I decrease the carbon footprint of the workloads running on the cloud? And the first thing that you can do to reduce that footprint, it's by avoiding waste, and right size your resources. It's estimated that 30% of cloud resources are wasted. They are either badly sized, they are over provisioned, there are virtual machines left running, there are orphan disks, over provisioning of compute. So the potential is huge there. So first you will start with right sizing. And what best than Wave Rider to automatically scale up and down and during the runtime of your job. So that's actually that's unique, because cloud native services, they won't let you scale up and down during the runtime. You'll need to stop and restart the job from the beginning, generally from the beginning. But with Wave Rider, it allows you to scale up and down according to the requirements of the job. Even better than that, it does it at lower granularity, at task level. So that means that it limits the over provisioning. You are not going to provision compute for the whole job, but instead you are going to scale dynamically according to the task's requirements. Then you want to avoid waste, and best thing to do it is with Spot Surfer. that first leverages Spot. So it was a bit introduced a bit earlier, but first it's the available compute power offered at discounted price by AWS, and generally you will find lots of this spot capacity for instances of previous generations. So I'm thinking that the C5s, the M5s, the R5s, so previous generation that can do a very good job. So instead of letting them go to rubbish, you can use them because they do perfectly the job for a lot of your workloads at a fraction of the price. And Spot Surfer manages spot potential interruptions and the lack of capacity so well that it really reduces the failure rate significantly by an order of magnitude of 10. So you won't need to start again your jobs because you run short of spot. It's already anticipated. It's very well managed by a spot surfer. Then there is another way that you will want to actually optimize this carbon footprint. It's actually with the time and place where you are going to run those jobs, because that matter. It's a new concept in cloud computing. It's called follow the sun. It's basically about picking the region with the best carbon intensity of the energy mix of the region and at the best time. So here you have a screenshot. It's taken from energymaps.com. This one, I think I've taken it in the evening. And you can see that you will see the regions with the best energy mix, the best carbon intensity of the energy mix. And then you will want to pick the region where you have the best, basically. So you do have to go for France or for Sweden, then for example, Poland. There is a bit heavy on lignite and coal in the evening. And also that varies greatly during time. So here you can click because you can see huge variations, huge variability. So you can click there. Maybe you see, yeah, this one, because yeah, you can see the variability, um, huge swings during the day, and that's according to sun exposition. For example, in Ireland, so you will see Ireland is like in the middle of the table. You can see it really fluctuates a lot from being a very good region to at night being quite bad. Also can be at night because there is less wind. So then you check Denmark, a bit higher up in the table, but also huge swings. And that's where you want to pick the region where there is also the region at the time where the carbon intensity is best. And because Memberge is a software solution, it means that you can deploy it across regions. And then you can schedule your job in the best region and at the best time of the day. You're not tied to region in particular. So yeah, thanks for giving me a bit of time to talk about the fact that Memberge, it's already great for cost and performance, but we can also highlight that it's not only about cost and performance and also about the sustainability of your workloads.